On the following slides, I will show you a very light introduction into application architectures for application programs. And the purpose is to get an overview. The purpose is not to be a specialist for application architectures. So you will not be able to develop architectures, but you will be able to understand what computer science people, what software developers mean when they use certain terms regarding the software architecture. So now, what does architecture actually mean? If you compare the architecture of a computer program, of a software, then there are quite similar criteria for an architecture. If you talk about an architecture for a building, then for example, you talk about a kind of high-level definition of the building structure, of the building interior, of the building utilities, things which are built into the building for the purpose of the building. And later on, when the building is in use, then the architect should keep in mind if it's for offices, for example, or for living. So adapted to the prospective usage of the building. An architect probably will never build a building structure from scratch. Of course, he has experience. Of course, he has some maybe building blocks in mind. And then these building blocks are, so to say, standard components or components which the architect usually uses, which he's used to use in the building architecture. And then the building architecture partially contains standard components. But also, if the client of the architect has some special features in mind for the building, then of course the architecture of the building can contain individual parts which are focused on the special purpose of the building. And these individual parts then maybe also contain a certain character for the building. Mostly the architect, even if he does not use standards components only, he will build the building, he will architect the building with a kind of best practices in mind. Best practices from former buildings, best practices from his education. And a very well-known book about best practices is written by Christopher Alexander. It's named A Pattern Language, Towns, Buildings and Constructions. And this book is from 1977. And the interesting thing is that software architects also sometimes refer to this book, A Pattern Language, because Christopher Alexander structured the world of best practices in a special way, and software architects at a certain point of time did the same. There is now in software architecture also a kind of pattern language, or some patterns are well known, and they are used as kind of building blocks. Now, how about the architecture for software? Software architecture, this almost the same as architecture for buildings, is a kind of high-level definition of the software and the system structure. It's not the detailed definition of each stone which should put together. And also, like the architecture for a building, the architecture for the software is focused on the future use of the software. So it's not focused on anything else, it's focused on the software use. As well as the architecture for a building, it contains standard software modules. In an architecture for a building, the standard components are used in the drawings, for example. And to connect these standard modules, the software architect needs to plan some glue code which somehow connects these standard modules. And as well as the architecture for a building, the architecture for a software also relies on best practices of former system developments, of the experience of the software architects, and on patterns as well. And the software architect, of course, has to keep in mind very different software architectures for different kinds of systems. We here in this short overview focus on 3 different architectures: on a desktop architecture, on a thin client architecture, and on a distributed system. Different architectures which might be important for your future work, and even if you are not a software developer, it gives you an idea how software can look like in application scenarios. In the following slides, we now look at some application architectures, and we use this graphical language for expressing some parts of the software. And I will rely here on this modeling method. It's a FMC modeling. You can access that on fmcmodeling.org, and there you can look into detail into the modeling methodology. But here it's only a short overview of the means you have in this methodology. So there are different parts you could model, you could describe with components in software architecture. First, there's a user interface. User interface means that you as a user, as a future user, should somehow have the possibility to interact with the program. You should input some data, some fields for putting in the data, some buttons to interact, whatever. It depends on the interaction which should be enabled in the program. You should have a certain view onto the data. So this is not only the direction from you as a user into the program, it is rather the direction from the program, from the database to you, presenting views on the data such that you are able to inspect the data and make some conclusions, for example. And also you should be able to call functions with buttons, for example, to start processes or to set certain statuses in the software in the states of the data objects. So this is the first main part. And you would model such a graphical user interface or a user interface with this combination of these 2 symbols here. You would symbolize the user with this person, and the component which interacts with the user is this rectangle here, and the combination, the connection between both is symbolized by this arrow here, by this 2-sided arrow. The second part is the logic. The user usually doesn't see the logic of the program, but the logic is essential for a computer program because the logic, so to say, controls the inner working of the computer program. It, for example, takes data from the database, or it takes data from the UI, and then it somehow processes the data with maybe algorithms, with maybe specialized algorithms for the application purpose. And the logic then outputs data, gives the data out to either the user or some persistence, some storage, some database. So the logic basically controls all the processing in the software. You symbolize the logic also with such a rectangle, and usually you write the name of the logic or a short name of the purpose of the logic into this rectangle, such that you know what this part of the software should do. Then the third part, which is important, is the storage part. The storage part, which somehow cares about the persistency for saving the data for a longer time. For example, on a hard disk, if you turn off the computer, then the data should still be saved securely without deleting. And this is one part of the storage of the memory. The second part is important for the data which should be held during the operation of the logic or during the operation of the application program. And this is mostly called memory. It's the RAM in your computer, which is deleted when you turn off the computer. And you symbolize this storage with these two symbols. In this FMC methodology, you mostly write this special rectangle with rounded corners, and sometimes also this cylinder is written for a database, and this means that the data are persisted for a long time there. So now we have the components, the graphical user interface, the logic, and the storage or the memory. And you somehow need to couple these parts. You usually couple it with interfaces. And interface means that you have some possibilities to connect to each component, but you of course need to talk the same language between these components. Such that if the GUI, for example, sends some data to the logic part of the application, like maybe shown here in this part, from the GUI there are some data transferred to the logic part of the application, then you should define an interface such that both parts can be connected to each other. A special connection is applied here for the connection from logic to some storage. As you see here, it refers only to the activities which is done by the logic in cooperation with the storage. So the logic would, in one case, write some data into the storage. This arrow stands for this writing into the storage, and on the other side, the storage might give some data to the logic to process something or whatever is required. And on the right side, you can see such a generalized architecture. It's a 3-tier architecture where you have some user interaction in the GUI, you have some logic, some processing for the data, and we have some storage. So in this application architecture, you would store some data, you would do some processing, and you would enable some interaction with the user. And special case for application architectures, you can combine now these components into different scenarios such that different standard architectures are achieved, architectures which serve a certain purpose for the application. So as said before, it is possible to combine these standard components, GUI, logic, storage, and so on, in different scenarios, in different combinations. And these combinations, of course, depend on the application purpose. So if you have a desktop application, for example, you would combine these components different than if you use it in a web application, for example. And what is also an important point to remark is that the different components do not need to be on the same hardware. They do not even need to be on the same hardware platforms like operating systems. They can be distributed on different platform types. For example, a central server of a web application is one platform with a Linux operating system, for example, and on a different hardware, on a different operating system, an Android or a Windows Phone or whatever, the other component runs. So one part of the application is the user part, the kind of GUI part, and the other part is the centralized server part with other logic. And here in this part of the presentation, we want to look into different architectures. Basic architectures are architectures for desktop applications, architectures for thin client systems, and the 3-layer architecture. On the right side, you can see a kind of 3-layer architecture, 3 layers for First layer, the graphical user interface, the part of the application with which the user interacts. Then there's some logic. The user does not interact with the logic directly. The logic takes data from the graphical user interface, and the logic communicates with the storage to get data from the storage. This would be the one direction, and to write data to the storage. This would be the other direction.